Welcome to Web Handling. My name is Dave Roisum. In this clip, we talk about some of the unique challenges of troubleshooting baggy film. We will also introduce the risk of widening the web on any process. Troubleshooting bagginess on film may be simpler than doing so on paper. The reason is that there are fewer forming elements. The heart of both paper and film are similar in areas of concern. In paper, we have a head box, and in film, we have a feed block. In both, we are concerned with flow vectors. Vectors mean both speed and direction as a function of cross-direction position. In film, we add concerns for shear rate, dwell time, and, of course, temperature. The only way to understand the head box or feed block is via advanced fluid modeling. Here, the paper people have an advantage because they have been doing this for 35 years. In contrast, modeling in film is only recent, and only a few of the more capable die suppliers have done this. The slice lip in paper and the die lip in film are identical in principle. Shape is very fussy for both. Smoothness quality is very fussy for both. Finally, changing thickness profile via actuators is fussy for both. In paper, nearly every actuator on every machine, except possibly the ends, are under automatic closed-loop control from a thickness scanner. In film, only a few of the newer and more expensive extruders are thus equipped. Again, the paper people have had a several-decade head start. While cast film has few forming elements, blown film has a few more, perhaps rivaling paper in simple count. We covered some of this in earlier clips in this series. Still, despite the higher parts count in paper, film has its challenges too. The biggest is that the corresponding parts in film are fussier for the simple reason that film tends to be much thinner. The thinnest film is about 1/10 the thickness of the thinnest paper. That stresses every design and maintenance aspect of every part even more. Recall that the winder may complain of web thickness variations of 1 to 10% of nominal thickness, and you can appreciate the problem of mere measurement, much less control. Recall also that while we have many similar concerns between paper and film, temperature is an additional challenge in film. We may need to hold temperatures of the film and everything the film touches to a few degrees to avoid thickness profile problems, and thus bagginess upon winding. While temperature is important for paper drying, it is not quite as fussy. In the next slide, we will introduce a challenge that is common across all the web industries. There are compelling economic arguments to increasing the web width on many machines. First, it is similar to increasing speed. You can produce more web with little more labor. Second, you may be able to serve more customer requests for even wider rolls. Third, even if you always sell narrower slit rolls, the percentage of width utilization improves with increasing web width. So why not run webs wider? One pretty hard limit is simple transport or especially process roller width. However, if we look closer, we see that web variability of all types tends to get worse towards the outside edges of the machine. In paper, half of all customer complaints occur on the outer 20% of the width. In film, the edges of the die and cast roller tend to be cooler despite our best efforts. These are just two examples of the scores or hundreds of troubles found on the edges of machines. It depends on how fussy you are in defining off quality. However, In the fussiest case, you may find edge damage going in 1 foot on film and 3 feet on paper. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for Baggy web troubleshooting challenges unique to other web materials. Also, please be sure to watch earlier clips in this series as well as Web201.05 through 09 as preparatory background. Oh, and of course, you should have all taken my Web 101 short course as essential background for any web challenge, and especially Baggy web challenges.